Okay, so I just threw 3 examples up there for us to work on, and a lot of you have this paper. It's got a blank side. We said there's a reason for that. And before I forget, the atomic masses that I want you to add together are Cu3, PO4, okay? So that's in the upper right-hand corner, right column, top one. Next one down, okay, left column, PB, parenthesis NO3, parenthesis 4. And then the next one down here, right column, it says nickel 2 carbonate, okay? So what I want you to do then, all right, is add together this one, write out the name, add the atomic masses. This one over here, write out the name, add together the atomic masses, and then this one down here. Nickel, we might not be able to see it, okay? This one right here. I don't know if I need to bring it in a little closer, if that helps. So this one, and that one. Okay, atomic masses. Okay, so what we see up here, there's a reason that we have these right next to one another. We see a formula. So what you have to do is write out the name of that compound. Well, what does SN stand for? Of course, that is tin. Okay, so if it's tin in this compound, it would be for this one as well. But notice we have CO3 all by itself here, and then we have CO3 down here as well, but that one's in parentheses. Well, why would that be? Well, it's because in this case the charges are going to be different, because CO3 of course stands for carbonate. Carbonate, if it stands for carbonate for this compound, it does for this one as well. Okay, and then in determining which one it's going to be, we said always go by your negative ion. Carbonate has a charge of -2. Okay, so we've got one carbonate ion that has a charge of -2. So to add up to 0, this tin has to have a charge of +2. So +2 minus 2, that adds up to 0. So this would be called tin 2 carbonate. Okay. Give you a little bit of time to catch up on that. Then as we look at this one, okay, still carbonate with a -2 charge. We don't have one carbonate ion, we've got 2 of them. So -2 times 2 gives us -4. And since we have one tin atom here, that would be a charge of +4. +4 and -4 would add up to 0. So this must be tin 4 carbonate. Okay, so that's the difference between these two. You don't have to guess what the charge of the tin is. That's what we're illustrating when we have that in parentheses. Okay, then that's what it's telling you here as well. We don't have to guess what the charge of cobalt is. We're saying that it has this type of a charge. So what I want you to do is just take a couple moments and go ahead and write that out. Okay, so we have this element cobalt, and its symbol is CO. Okay, and then we've got the polyatomic ion of hydroxide, which is OH. Okay, and cobalt can have various charges because it's a D block element. Now, not all D block elements are going to have multiple charges. An example of that would be zinc. That only has a charge of +2, even though it is a D block element. But in this case, we're telling you that this cobalt has a charge of +3. But in order to write these out, we say start with their negative ion. Hydroxide is -1. And then, of course, this cobalt is +3. Those do not add up to 0. So what is your least common multiple between those? Excuse me. And if you said 3, that would be correct. And when you divide them into 3, the answer that you get tells you what to put below for subscripts. Okay, so in this case, 3, and if you still prefer to do this, there's nothing wrong with doing that simple math rather than trying to do it in your head. Okay, so again, this is not a value, it's just a charge. We've got 1 hydroxide ion right now. So 3 divided by 1 gives us 3, but this is not how we write it. Because notice how we had this example up here. Okay? Notice we don't have CO3 and then 2. We don't have 32 oxygens. We want 2 carbonate ions. So this is the same type of concept. We don't want 1 oxygen and 3 hydrogens. This whole thing has a charge of -1, but we want 3 hydroxide ions. So we put that in parentheses, just like what we had illustrated up here. And then 3 divided by 3 gives us 1, and we've got 3. So that would be the correct way that you would write out cobalt-3 hydroxide. Then the last thing that you would do is add together the atomic masses, and in order to do so, just bear with me for a moment. Let me get out a periodic table. Okay. So of course, even if you went to the internet, you could use one just as long as it has the atomic masses in here. In this case, I've got actually an organic and biochemistry book, but yet still has a periodic table in it. So with that, we'll just do these two, because these are probably a little more tricky than the top one, because with this one oxygen atom has a mass of 16. You got 3 of them, so 16 times 3 gives you 48. So 48 for your oxygens, 12 for your carbons, so now you're up to 60. And I think tin is 118 maybe. So find Sn, element number 50. So yes, it's 118.71. So 118 plus 60 would give you your atomic mass for tin 2 carbonate. So we're going to work on these now. So 118 for tin. Okay. Now this one's a little more tricky. We're not adding these. You distribute that 2, and then you got to multiply them. So now we don't have 1 atom of carbon. We've got 2. So 12.01 times 2, okay, gives you 24.02. Okay. And then we don't have 5 oxygens. We've got 6 of them. You don't add them. You multiply them. And then when we do that math, 1 oxygen, 16. 16 times 6, okay, give you 96. So then go ahead and add them together, 7, 3. Then we've got 8 and 4 is 12, plus 6 gives you 18. I guess I'm trying to make that decimal a little bigger. Carry your 1, there's 2, 4, and 9, gives you 13, 1. So we've got 238.73 is the atomic mass for this, 238.73. Okay, then let's go ahead and do your cobalts. Go ahead and take a little bit of time and add those together. Okay, so let's go ahead and proceed with what we see here. Remember, we distribute that through there. Okay, so 1 oxygen is 16, but we've got 3 of them. So 16 times 3 gives you 48. Okay, 1 hydrogen is 1.01, but we've got 3 of them. So therefore, we've got 3.03. Okay, and then cobalt is element 24, I think. No, that's chromium. Cobalt is 27, so that's 58.93. Add them together, and if you do it in this manner, or if you use a calculator, okay, it doesn't really matter. We just want to get to the right answer. So 48 plus 3.03 plus 58.93, and that gives you 109.96. 109.96 is the atomic mass for cobalt-3 hydroxide. All right. So hopefully that gives you a good start on this paper. Okay, and a lot of you turned in what was required yesterday, and we said that we're going to hand this out for you to work on, and it's not something just to say, oh man, we're just handing something out to keep you busy while we're away. It's actually a good review for some of us. And the back side, we said there's a reason why that is blank. Your student learning objectives that we had worked on, okay, is a lot of what, well, not a lot, it is what your next chapter is over. So in this case, we're just going to work on balancing some chemical reactions. We're not going to do a whole lot, okay, because again, that's a chapter away. But one of the things that I like to do is just like if this was a class of anatomy and physiology, I give them names of bones and muscles well ahead of time before I assign them. So it's something that doesn't sneak up on them, okay? So I want to give you some of these reactions and how to balance them so that does not sneak up on you. So we're going to keep it really, really simple here, okay? We're going to do H2 plus Cl2, and when those react, gives us HCl. Okay, then we'll do something perhaps a little more complex. We'll just do, since we had cobalt, okay, we're going to add that to an acid, since that's what we produced up there. And in this case, we'll just go ahead and keep it as cobalt-3. That's important because we'll have you finish this in just a moment. So some of these concepts you just don't know yet because you haven't been taught that yet. But a lot of these we have, okay, because this is how hydrogen bonds together, and then chlorine, oops, and then dot. Okay, so there's your chlorine molecule. So what happens is as these react with one another, it's not that they disappear because you're going to say, well, we've got two chlorines here and there's only one row down over here yet. Well, again, that's something that you just haven't learned yet, but it was part of your student learning objectives. It's based off of content or prior knowledge that we do have. So one of the things that we do is below the arrow, we just see the elements that we see. We see hydrogen and we see chlorine. Okay, I should lower that just a little bit. And we see chlorine. Okay, so the subscripts tell us how many we have. We've got two hydrogens on the left and only one hydrogen on the right. We've got two chlorines on the left and only one chlorine on the right. Okay. So this is where we're going to count for having two chloride ions on this side and only one over there. Because what happens is you distribute what's called a coefficient, and that goes all the way through the compound. Okay? So upon doing so, we just multiply 2 times 1. Oops, I don't know why I put 2 up there. I got a little ahead of myself. So 2 times 1 gives you 2. 2 times 1 gives you 2. So that is now balanced. We've got 2 hydrogens, 2 hydrogens. We've got 2 chlorines. 2 times 1 gives you 2 chlorines. Okay. This next one is maybe just a little more complex. So I want to try to keep this under 15 minutes. We always say go by your negative ion, okay? And that's -1. You'd have to be told, like from the previous example, this was cobalt-3, so we're going to keep that charge the same. So notice this does not add up to 0. Your least common multiple is 3. dividing each one of these by 3, the answer you get is what you put below. 3 divided by 1 gives you 3. Okay, so now we're going to go through and balance this reaction then. Okay, so upon doing so, this one's a little more tricky because what happens is if we put a 2 here, we're already going to be in a bind here because 2 times 1 gives you 2, and we got 2 hydrogens, and 2 times 1 gives you 2 for your chlorines, but we've got 3 of them over here. So the problem with that is we actually have to double this, and that's something that you'll get better at when we arrive at this in our next chapter. 2 times 3 gives you 6, so that means we have to put a 6 here. Okay? Then for hydrogen, 6 times 1 gives you 6, so we have to put a 3 here. We've got 2 cobalts there, so we have to put a 2 there. Okay, that one might have been a little more complex. We're not here to try to lose anybody, and please don't feel intimidated by this yet. We're just starting to get a head start on this, so once we do get to this portion, we become really, really proficient at it. All right, so that's all I have. Hopefully, we'll be back in class together more than likely on Friday, but we'll see how that goes. Otherwise, please tune in tomorrow and we'll do some more reactions like this. All right, that's all I have. Stay safe and we'll catch up to you next time.